Hi, it's Mr. Anderson, and in this podcast, I'm going to talk about this word right here. Ecological, well, it depends on where you live. Some people call it a niche. Some people call it a niche, and some people even call it a niche. And so I tend to call it a niche, but I think that's kind of an American thing, and so whatever we call it, it's derived from a French word which simply means nest. And so a good way to think about a niche is basically your role in an environment. And if we look right here, we see a couple of niches being exploited. And so we've got a rock here, and then we've got lichen that's growing on the rock. And so I can actually see 4 species here because lichen is not one species. It's actually a symbiotic relationship between an algae and a fungus, and they can't live by themselves. But I can see this green lichen, and then I also see this orange lichen growing right here. And they're both exploiting a different niche or a different job. And so one of the first scientists to come up with a good definition for a niche is this guy, George Hutchinson. I love his hair, and I've never been able to figure out what kind of an animal he's holding. It looks maybe like a cat or a monkey. But he defined it as an n-dimensional hypervolume, and so that seems like a crazy term. So what's he really talking about? Well, he's saying let's put on one side some biotic factor or abiotic factor. Let's say on this side we put sunlight, and on this side we put moisture. Well, this is just a 2-dimensional volume, and so basically, or area we would call that. And so let's say that you're an organism that likes a lot of light, so you could survive there, but you don't do well with moisture. Well, then this would be your niche right here, and so it would be this area. But he says there are so many different characteristics, both biotic and abiotic, so we could add temperature, food, predators, all those things. So if you think of each of those being a different dimension, then you would have this complex n-dimensional hypervolume, and it would be this shape that only a species can fill, and none of those species can overlap. So we're getting a little deep. Let me tell you what I'm talking about. So let's say we've got the orange lichen. And the orange lichen likes a lot of sunlight, doesn't do well without sunlight, but can't stand a huge amount of volume of moisture. And now if we look at the green lichen, well, the green lichen likes more moisture, but doesn't do well if we have a whole bunch of sunlight. And so basically, if we put those in the same area at the same time, we're going to see 2 niches. The first one is your fundamental niche. And so your fundamental niche is where you could live. And so in other words, for the orange one, the fundamental niche is going to be this whole area. It could live here, but when you have the green lichen show up, it can't. It's being outcompeted by that green. And so now we would have to give up this section. This actually belongs to the green. And so now the realized niche of that orange lichen is just going to be this shape right here. And so that's one way to think about a niche. Another way to think about it is simply its job. And so let's say you work in a factory. This is an early Ford assembly line. Basically, each of the workers in here have a specific job or a role within this factory. Likewise, in a coral reef, each of these corals is going to have a different role that they play within that ecosystem. And so they're constantly in competition with each other. And in fact, we have what's called the competitive exclusion principle. And that essentially means that you can never have 2 different species filling the same niche at the same time. A better way to say that is that complete competitors, in other words, 2 species that are in complete competitions, doesn't even exist. It's like a fairy tale. And so let me tell you a real story of how this actually plays out. And so this is a coyote, this is a fox, and then this is a gray wolf. And so we didn't have the gray wolf in Yellowstone Park for a long time. And so basically, when the gray wolf was gone, the coyote started to fill that role. And they started to have weird pack-like behavior, and they started to do really well, fill niches that were at one time filled by the gray wolf. As they did that, the red fox population actually went down. They took a hit. And the reason why is that the coyotes were exploiting that niche. Well, now we reintroduce the gray wolf into Yellowstone Park. The gray wolf actually is killing coyotes by the thousands. And so when we introduced the wolf into Yellowstone Park, almost immediately 50% of the coyotes were gone. And that's because they were in competition for the same food source, the wolf and the coyote. And so the wolves would target them and kill them. And a pack of wolves against a coyote is no competition because coyotes kind of live this solitary life. They'd simply kill them. And so basically what's happened is the wolves have now taken over that niche that was being filled by the coyote. As a result, now there's less coyotes, and so you could imagine that the red fox population is starting to take off, and so that's pretty cool. Right now, if you go to Yellowstone Park, We've seen selection, and so now we're seeing coyotes that are much larger than they used to be, and they tend to spend most of their time around the roads so they get protection from humans. That's it. That's all I've got on the niche, and I hope that's helpful.
The word ecosystem is short for ecological systems. An ecosystem is a place where living things such as goannas and non-living things such as rocks live in a shared environment. An ecosystem can be small as a pond or as large as an ocean. Scientists talk about general ecosystem types. They call them biomes. A biome is a group of ecosystems that have a similar climate and have a similar plant and animal species. There are a number of different types of biomes, including freshwater, marine, desert, forest, grassland, and tundra. Let's start with freshwater. Freshwater is defined as having a low salt level, usually less than 1%. Places and animals that live in freshwater ecosystems would die if they were placed in water with high levels of salt. There are different types of freshwater areas, including ponds, lakes, rivers, streams, and wetlands. Marine regions cover about 75% of the Earth's surface. Oceans and coral reefs are examples of marine biomes. Marine regions differ from freshwater regions as they have high levels of salt in the water. It's home to millions of species of animals. A desert is an area that receives less than 50 centimetres of rain each year. They're extremely dry places and cover about 1/5 of the Earth's surface. The Simpson Desert occupies approximately 176,000 square kilometres of Central Australia. Forests cover about 1/3 of the Earth's land area and are made up of many trees. Trees breathe slightly differently from humans and other animals. Trees breathe in carbon dioxide and exhale oxygen. Humans need oxygen to breathe. That's why it's important that we protect our forests. Grassland ecosystems are land areas that are covered by grasses. Grasslands can be split into two groups: savanna and temperate. Savanna grasslands are always found in warm, hot, or tropical climates. The savannas of northern Australia, including the Kimberley region, are typical of this. Temperate grasslands exist in varied climates, with cold winters and hot summers. Australia's Kangaroo Island and Cradle Mountain in Tasmania are examples of these biomes. The tundra biome is the coldest of all the biomes, like Churchill in Manitoba, Canada. Tundra ecosystems have very low temperatures, are covered in ice, and don't have much rain,